Last topic of the unit. How do areas compare when two figures are similar now? Right? So first thing I want to do is go back to our similar, we talked about triangles, but this is just any figures in general. Two figures are similar. This is a review for the Regents coming up in a month and a half. Two facts I know about them. If I know two figures, I'm not talking triangles, so don't give me angle, side, I'm not concerned. Two figures are similar. What do I know about them? Let's start there. Hi, Nick.
They're proportional.
What's they?
The two figures.
Figures. Something else is in proportional. I don't like the figures. I don't know what that means. Like this pentagon over this pentagon equals star over this star. What is it? Sides. Thank you. Corresponding sides proportional. Gonna run out of room. So, if that's 6, and let's say that's going to be a 2 here, that could be 12, and that could be, 4. Okay? Sides are proportional. All right? And corresponding angles congruent. Yep. So I just wanted to remind you, if two figures are similar, this is what happens. Today, how do their areas compare then? All right, there's a special relationship. And also, I know we're in the area unit, but we're also going to look at perimeters too. How do their perimeters match up? All right, so instead of just giving you that fact, like usual, we're going to find out as a big group and in your mini groups here. So first thing, on the back, second page of your notes today, you're going to see a piece of graph paper. That's for you to use if you care to use it, because you can't answer the question without it. That's fine. Go ahead and use it. We're going to construct 4 rectangles. All right. First one, I'm going to tell you the dimensions, and then the other 3 you're going to come up with for me. The original one, I want you to write this right next to it so we remember. The first rectangle is going to be 3 by 4. All right, 3 units by 4 units. Now, if you want to make a 3 by 4 on the next page, you can. Here's what I'm going to ask somebody. What's the perimeter and area of that 3 by 4 rectangle? Okay, so if it helps you out, graphing it on the next page, feel free. If you can do that in your head or on your calculator, go ahead and do it that way. All right, so if I have a 3 by 4 rectangle, what's my perimeter of it and what's my area? All right, what do you got for me here? 13 perimeter. 14, and how about the area? 12. Yep. Add up the sides, length times width. All right, now I need your help. Rectangle number 1 has to be similar to my original, meaning corresponding sides have to be in the same ratio. They have to be proportional. So you make up your own right now and you let me know. What size is rectangle number 1 going to be? And it has to be proportional. It has to be similar to my original. All right. The sides need to be in the same ratio. 26, your show.
6 by 8.
All right. That's whatever I usually get there on the first one. 6 by 8. Yep. All right. Same thing. What's the perimeter and what's the area? 6 by 8 rectangle. What's your perimeter? What's your area? All right, when you're ready here, perimeter and area. 6! It would be.
And the area would be 48.
There you go. Good deal, good deal. All right, next up, give me another similar rectangle, please. Similar rectangle to the original. 3, you're up.
30 by 40.
This guy. 30 by 40 works. It is true. It is true. Hey, perimeter and area for this one. Oh, 6, back to you.
The perimeter would be 130. And the area would be 1,200.
Thank you. Thank you. All right, this last one, can we get smaller maybe? We've been blowing them up. Can we reduce it a little bit? Give me something with a little smaller than 3 to 4. That's still similar to the original. What do you think here? 2? Got anything smaller?
No.
Great talk. Great contribution as usual. Will, you're up. You owed me one from last week.
That's not well.
No, he said I owe him.
It's not your number.
Yeah, but still.
Will somebody let her know? Let me teach the class. Okay. You owe me one.
0.75 by 1.
1.5 by 2. I love it. Yep. I love it. Yep. Great one. Great one. Thanks, Will.
No problem.
All right, 25. You're up now. Perimeter and area.
Perimeter 7, area 3.
7 and 3. Good. All right, there's definitely nothing I noticed yet, but there will be now when we fill out the second table. First, let's talk about this term we've used a lot, but has been a while. Similarity ratio. That's it. Hey, that's just the side ratio. Give me the ratio the sides are in, and I'll give you a heads up tonight. Your textbook doesn't use either. It uses scale factor. Okay, so basically take 2 corresponding sides. What's the ratio? Okay, what fraction are they in? What's the ratio? So first, 1 to the original. Everyone look at 1 to the original. Give me the side ratio, the similarity ratio, scale factor. 25 again. Go 1 to the original, look at 2 corresponding sides and give it to me.
3 to 6.
1 to the original.
Oh, 6 to 3.
6 to 3, I'm going to reduce that to, that's a ratio of 2 to 1. Can everyone now look at their perimeters and do the same thing for me? What ratio are their perimeters in lowest terms? Lowest terms. So if you got to go to the calc and reduce, do it. Lowest terms. What is their perimeters in? 25 again. 3-bagger. So what's the perimeter of number 1?
28.
What's the perimeter of the original?
14.
28 over 14 reduces to?
2.
2? 1. Right?
Okay.
2 to 1. Oh! Why don't we just write in 2 to 1 for the areas? How about no? What's the ratio of their areas now? Look at their areas. It will not be 2 to 1. Instead, 8. 48 to 12. 4 to 1. Maybe we're noticing a slight pattern. Maybe probably not, though. All right, now everyone look at rectangle 2 in the original. Give me the ratio of 2 sides. Similarity ratio. 7. 10 to 1. Woo. All right, now do perimeters, everybody. Perimeters. What's the ratio of their perimeters and reduce down for me? 9 to 1. Thank you. And then how about the areas? Ooh. It's the ratio of their areas. Big boy number, big girl number here. 8? 100 to 1. Maybe establishing a pattern now. We'll see. And then finally, let's go to my smaller rectangle. Rectangle 3 to the original. What is the similarity ratio there of 3 to the original? Go in the right order. 21?
1 to 2.
1 to 2. Good work, Dan. 1 to 2. Perimeters. Perimeter ratio, 26. 1 to 2. And then how about my area ratio? 7. 1 to 4. All right, so let's see if we found anything out here by answering to the next question. How do the ratio of the perimeters and areas compare to the similarity ratio? So let's start with the perimeters first. Similarity ratio. What do you notice about the similarity ratio and the perimeter ratio? Please just look at the darn chart. Similarity ratio and perimeter ratio. What do we notice? 5? They're always equal. All right, they are equal. Not true for the area, though. So I'm going to write this, but it's going to be completely false. I'm going to ask you guys to adjust it for me so they are equal. So similarity ratio equal to the area ratio. This is a false statement, as you can see from your chart. How do I adjust it, tweak it a little bit so they are equal? So what am I? Hey, similarity to area. Similarity to area. Similarity to area. How do I tweak this bad boy so they are equal? Take a look at the chart and the numbers. How can I play around with those numbers so they're always equal to the area ratio? What am I going to need to do here? 25. What am I going to need to do that similarity ratio?
Square it.
Square it. Everyone agree? Square it and you get the area ratio. Yep. Good. All right. All I want to do on the next page where it says theorem is to write this symbolically now. All right. Because we're not going to write out similarity ratio, perimeter, and area ratio every time. All right. So symbolically, here's what we just learned for theorem. S1 over S2. What do you think I mean by S? Side similarity ratio. Yep. Scale factor of one to the other is always equal to. If I know this ratio, I know the what ratio? Let's go back again. 16. If I know the ratio of two sides, I also know the ratio of perimeters. P1 over P2 for perimeters. All right, if I know the similarity ratio, I also know the areas, but they're not the same, right? They're not the same. What do I need to do to figure out the areas? What do I need to do to my side ratio? Similarity. 20? Square them. Yep, square each of them, and then you'll get that area ratio. All right? All right, great. You know the rules now. How do I work with them now? How do I use them? Here we go. All right, I'm telling you, these figures are similar. I already know. Similar. These figures are similar. Got to have that, by the way. If I don't have this, everything we just talked about means nothing. Squat. What's the ratio of their perimeters and what's the ratio of their areas? All right, can somebody first give me the side ratio or the similarity ratio here? It's right there. All right, what's the side or similarity ratio? 4. Remember, just you're overthinking it, Alicia. Take two sides that you know and give it to me. Over. That's it, right? Just so we're all clear, when I ask for S1 over S2, the side or similarity ratio, all you guys are doing is taking a side from one of them and matching it up with the corresponding side from the other one. All right, that's all I'm asking for when I say similarity or side ratio. All right, now, how about that perimeter ratio it's asking me for? P1 over P2. What's the ratio of the perimeters here? 18? Also 4 over 5. They're all equal. Now, we got to take a time out here. I want to make sure we're clear with something. Am I telling you that the perimeter of the smaller figure is 4 and the perimeter of the bigger figure is 5? No, I am not. That's ridiculous anyway, right, by looking at that. That is not telling you what the actual perimeters are. It's saying if you found the perimeter of the smaller one and put it over the perimeter of the bigger one and reduced it, you know what it reduced down to? 4/5. That's what this is saying. Do not get this confused that this is giving you the perimeters. It's not. Whatever the perimeters were reduced would be 4 to 5. Okay, so don't think this is the perimeter. No, it's not. All right, what about the areas then? Or the ratio of the areas? A1 over A2. How do I get those values? 25.
16 over 25.
How'd you get it?
Multiply it. Square them. Oh my god.
Square them, yes. 16 over 25. And again, I'm going to go nuts here. Am I telling you that the smaller one's 16, that area? No. The bigger one doesn't have an area, maybe, I don't know, but doesn't. But I can tell you when I do find them, they'll have that ratio. All right, so please don't think you're finding the perimeter and areas doing it this way. Questions? All right, I'm going to get a little tougher now. Not really, but here we go. By the way, review. I didn't even need to tell you these were similar. How would we know already? Darn right! Angle. Been trained like beasts this year. Now, how about S1 over S2? Raising machines. I see that the smaller triangle has a side of 3. Whoa! How are you going to find which one that matches up with? Right? Because it's got to match up with the 5 or the 8. And you're darn right not being in this class. You're not going 50-50 on me. 100% confidence. Which one does it match up with? If you're concerned, put the congruent angles smack on top of each other. If you can do that visually, put the congruent angles on top. And what would the 3 be on? All right, what's the 3 correspond with? 5? God! Happened in the other class. All right, let's go. Here we go. 24. And 21. 8 over 32. All right, now I'm rattled. Let's try. 8 over square root 32. There we go. So side ratio, similarity ratio, 1/2. Can we just have, before we find it, quick discussion about 4 circles? I thought S1 over S2 was sides, and that's why I don't like using the word sides. I like similarity ratio. When we say that's any corresponding parts, all right, because you're probably like a circle. Circle doesn't have sides, but give me some things in a circle we know of that we can measure. Okay, radius. That means the radii are in this ratio we're about to find. Anything else we can measure? Diameter, chords, any of those are in this ratio coming up. All right, so I just didn't want you to think, we can't do this problem. All right, all S1 over S2 means it's 2 corresponding parts of the figure. Could be sides, could be anything else. All right, so A1 over A2 is 128 pi over 18 pi. You can notice the pi's are going to cancel or just plug them in your calculator. That's we just did with problem 3. And yes, I am going to square root this. And when you're ready, what do you have here for me? 13? 8 over 3. Thank you. Great work. All right. Great work, everyone. Great work. Now, here's where all this comes together now. All right. It's this last problem. Here's where I need you to be. We got 2 similar rectangles. All right, just for a little visual here. You don't need to put one on your paper, just a little visual. We got a big one, we got a tiny one. All right. Shorter side of a rectangle is 6. The shorter side of a similar one's 9. So shorter, we got 6 feet on one. The shorter on the other is 9 feet. Okay. Area of the smaller one is 48 square feet. What's the area on the bigger one? Right? I don't want to do this by doing, length times width, so that's got to be this, and then that. I don't want to do it. I want to do it using the rules we've been using. So if you're doing this right now, there's the side ratio, 6 over 9, right? That's equal to, let's see, 48 belongs to the smaller rectangle, so it's across from the 6. What's the area of the larger one? If you're writing that down, I didn't do a good job today. Okay? If you're writing that down and solving it, keep it there. Keep it there. If you're solving it, I didn't do a good job. Because what are you telling me right now? The side ratio is the same as the, what's the 48 again? That's area, right? Is that true? You're telling me S1 over S2 equals A1 over A2. False. Adjust it for me now so I can cross multiply. Because you're not cross multiplying right now. That's a false statement you have written there. Adjust it for me so I can actually solve this problem. 5, how can you adjust this bad boy?
Square the 6
Square the 6 and the 9, or if you're really looking for some punishment, I guess you could square root the 48 and the x. Right? I'm not too sure how that would go solving wise, but maybe. Square the 6 and the 9. Yep. That's where I need you to be. Actually finding the area of a figure based on its ratio. And then you could cross multiply. How's the temperature level? How do people feel about it? Good. Good. To the point I should crack a window, but you don't get fresh air in math jail. So again, I don't know if I said this last week, but you're lucky you get to look out the window. And the blinds aren't closed. So what do we got here? What's the area of the larger rectangle? What are we looking at? 8. 108 square feet. Again, please make sure you have the correct ratio before finding the area. Okay. Whoa! What course are we at? Honors. What if I said the perimeter was 48? Find the perimeter of the larger one. What would I set up instead to solve now? What if I said the perimeter? I changed that A to a P now. How would that look now? Think about it. If I asked you to find the perimeter. 10?
Would it just be 6 over 9, but not squared?
Correct. I've used the incorrect one I had before. 6 over 9 equals 48 over x, because what do you know is x sides are equal to perimeter, and I'd solve that instead. There you go, boss. Good job. Glad you were here when I called out. Other questions? All right, plenty of time here. Should be able to finish. There's only a handful of problems out of the textbook.